Okay, all right, so what we want to do is we want to find the explicit formula again. So if I write out my, it's going to go slow again, isn't it? Two, the latecomers are coming, 2, 7, come on computer, 2, 7, 15, 26 and 40. So this is from practice 6, which is page 284, and this is question 1H I'm working on. Okay, so what I'll do actually is I'll do a quick recap of the algebraic method and then we'll compare. All right, so in both methods, actually the first thing we need to do is determine if it's linear or quadratic or neither. So we're going to look at the differences between the terms, right, to find the first line of difference. Right, so the first line of difference here, we've got +5, then we've got +8, then we've got +11, and then it's +14. So first line of difference, so we know it's not linear. All right. So we then look at our second difference. Come on, computer, don't slow down on me. Am I lagging or anything, by the way?
Yeah.
Slightly. Okay. All right. So it keeps changing. I'll re-plug it in. All right. So the second line of difference, which would tell me if it's a quadratic or not, if I look at that, I can then see, well, this is +3 every time. Okay. So what we then do, if we're working from sort of the absolute fundamental principles of what we've been talking about, if this is the first term, the second term, the third term, the fourth term, the fifth term, that means n is 1 here, n is 2, n is 3, n is 4, n is 5. And we would find these numbers by putting this number into an squared plus bn plus c. So this, when n equals 5, this should equal 40. All right. So we're going to use this, but we're going to use it as a general sense and say, right, if I didn't have these particular numbers and I just did it in terms of a, b, and c, well, when n is 1, the first term here would be a times 1 squared plus b times 1 plus and so on. And when n is 2, it would be a times 2 squared plus b times 2 plus, when n is 3, a times 3 squared plus b times 3 plus, and so on. That makes sense to everyone, yeah? So we've got this simplifies to a plus b plus c. This is 4a plus 2b plus c. This is 9a plus 3b plus. So what I can actually do is up here I can say I already know that 2 is found by doing a plus b plus c. Okay, 7 is 4a plus 2b plus c. 15 is 9a plus 3b plus c. And 26 would be 16a plus 4b plus, and so on, right? Okay. The next line of difference, well, if I worked out that difference between those, I'm getting the 5, I'm getting the 8. And what do I end up with? Well, subtracting these left me with, well, this was 3a plus b. This one is 5a plus b. So I know these two numbers match to 3a plus b, and 8 would be 5a plus b. If I then go the next level down, I can see that it's just 2a, and it would always be 2a if I'd have carried on. So I know that 3 has to match with 2a. All right. So if I just write this off to the side, I actually only need this one, and this one. I could use any of them, but I might as well just pick the three easiest with the lowest coefficients. So I can say that a plus b plus c equals 2. I can say 3a plus b equals 5. And I can say 2a equals 3. So I can use those equations one at a time and say, well, in this case, a must equal 3 divided by 2. Okay. So a is here, so I've got 3 times 3 over 2 plus b equals 5. All right, probably need a bit of space now. 3 times 3 over 2 plus b is 5, so that would be, well, 4.5 plus b, so what equals 5? So what would b be? Yeah, b would be a half, or 0.5. So I can then chuck that up here, so I know if I change 3 over 2 into 1.5, so I've got 1.5 plus 0.5 plus something has to equal 2. Now in this case, 1.5 plus 0.5 is actually already 2. So I know C must be 0. Okay. So then I can say up here, this formula for the quadratic, well, it's got to be 1.5n squared plus 0.5n plus nothing. Okay, and that's it. So un equals, and that's the formula. And that's doing it the algebraic way. All right. Sound all right? Did that clear anything up for anyone, or was it a bit too quick? Bit too quick. What are you confused with?
How do we find out c equals 0?
Well, what's 1.5 plus 0.5? 2. So 2 plus something makes 2. So what must the something be? Yeah, 2 plus 0 has to equal 2. So I know the c has to be the 0. By the way, this follows on from that video from last lesson. So if you weren't quite so sure, you probably should have been asking for the connection to that video, guys. I only had 2 people request access to it. So remember, maintain your greatness and ask for help when you need it. Okay. All right. Well, even if we have to come back to that, what I'm going to do is I'm going to go through the other method. So the other method might make you think, oh, that's better. Or you might think, oh, that's even worse. All right. So I'm going to do the same question again. So 2, 7, 15, 26, 40. And it's the same process. So what in your head now, scratch that algebraic stuff. That hasn't happened. All right. So let's just start in exactly the same way. There's no reason why I'm doing curves instead of squares. I don't know why, but you know. So we've got plus 5, plus 8, plus 11, plus 14. So we know it's not linear. Okay. We do here, it's plus 3, plus 3, plus 3. Okay. Now this method, because we're not relying on the algebra, this number here, we know it means quadratic, so we know it's an n squared, but what we don't know is how many n squareds. This is the unknown, okay? Now, for those of you that didn't do the algebra yesterday and you did just use the book method, how do you decide what the question mark is from this number? Owen, I saw you didn't use the algebra method, you used the book method. So what's this? How do I link this number to the question mark? Oh, is he not here anymore? No, it's gone. All right, anyone else?
Just reading it from the book, it says that the coefficient of n squared is half of the value of the second difference.
Yeah.
So it would be 1.5.
Exactly. So basically, guys, it's going to be another page. If we'd gone through that process, what we would have done is said, right, well, let's work out what 1n squared is. Now, 1n squared is just the square numbers. It's 1, 4, 9, 16, 25, 36. You're all okay with that, yeah? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, the square numbers, right? If I work that out as a sequence like I'm doing, I'd have worked out that the second line of difference is plus 2, all right? Then what I say, right, let's do 2n squared, and you've got, well, that's 2, 8, 18, 32, 50, 72, and so on, right? And I'd have worked out that the second line of difference would have been plus 4. And then we'd have gone on for 3n squared, which is 3, 12, 27, 48, 75, and so on, right? And I'd have got the second line of difference would be, what do you think? Plus
6.
Plus 6, yeah? So what we're looking at is when it's 1n squared, we end up with a plus 2. When it's 2n squared, we would end up with a plus 4. When it's 3n squared, we'd end up with a plus 6. And I can show you that that is what's actually going to happen, look. So let's do it with this one. 3 plus what makes 12? 12 plus 20, 27 minus 12 is plus next one. No, you're not. I've just moved on to the next one already. Maybe I'm lagging. 27 plus what makes 48? 48 plus what makes 75? 27. And you'll notice, look, that the second line of difference is plus 6. Okay. So what we would have then done is said, all right, but what if it's plus 3? What if it's plus 5? We haven't got them. They seem to have been skipped. Well, that led us to would have led us to the conclusion that if it's plus 3, well, look, plus 2 is 1, plus 4 is 2. So we take this number and divide it by 2. So this would be 3 over 2 n squared. This one would be 5 over 2 n squared. If it was a plus 7 for the second line of difference, what would it be? How many n squareds?
2n squared.
Exactly. 7 over 2 n squared. All right. Or, in old money, 3.5 n squared. Okay, so we use that. Let's go back up to this problem. So we now know, because it's plus 3, this question mark is going to be 3 over 2. But we don't know what comes afterwards. All right. So what we do is this. We write down, so I'm going to say that's 1.5 n squared. We write down a little table, okay, when n is 1, 2, 3, 4, 5. Okay. We know that un is, in this case, 2, 7, 15, 26, 40. And what we currently have is 1.5 n squared actually gives me what? So we have to work out what 1.5 lots of 1 squared would be. Well, that one's easy. That's just 1.5. All right. What would the next one be? This number here. It would be 1.5 lots of 2 squared. And what do I get?
5 times 4.
1.5 times 4, which is?
6.
Okay. This would be 1.5 times 3 squared, which is?
13.5.
Okay. This one, 1.5 times 4 squared. 24. 1.5 times 5 squared equals?
5.
Okay. So here's the thing. All right. I'm going to give myself a bit of space. All right. So the thing is, this is where I want to be. These are the numbers I need to describe. These numbers are where I'm currently at with my first decision, and my first decision is based purely on this. All right. So these numbers come purely from that part. But as you know, a quadratic could have another part to it. Come on, computer. All right. So this is purely the an squared bit, but we're still missing a possible bn plus c. We're missing a possible linear part to this quadratic. So a quadratic is made up of a quadratic part and potentially a linear part and a constant part. And obviously, because the quadratic part hasn't given me quite what I want, all right, there must be a linear component or even just the constant to it. So what I have to do is I have to consider how far away am I from where I need to be. Okay, so what I do is I say, right, what's the difference between these things? Okay, does that make sense? So I've got to say, well, it's going to be 1.5 n squared, the difference between that and un. So I'm going to do un minus 1.5 n squared, and I get the answer. Well, in this case, 0.5. In this case, it's 1. In this case, it's 1.5. In this case, it's 2. In this case, it's 2.5. Now, what do you notice about that?
Constant difference.
Okay, we now have a linear sequence in its own right. Okay, so this is the bit we have to add on to this part to give me where I want to be. So we can say, because I don't normally do it like this myself, but I know it's in the book. So we can say, well, un minus 1.5 n squared is equal to, well, what is this? How would I describe that? Well, go on.
Would you do like plus 0.5?
Yeah, so this one is plus 0.5 every time. So how do you describe that as a sequence? Well, this on its own would be 0.5n because it's a linear thing, yeah? And is that it? Do I need to add any constant in or not? Well, 0.5 times 1 is 0.5, so it doesn't look like there's a constant bit at all, right? So this is our linear part. So this bit here is equal to 0.5 n. Make sense? Okay, so now it's just a case of rearranging it. So I'm going to make un the subject. So I'm going to say un equals, I'm going to add 1.5 n squared to both sides. And I'm going to have it as 1.5 n squared plus 0.5 n. And I think if we go back and check, that's what I ended up with up here anyway, didn't I? Okay, 1.5, 0.5 and 0. So I thankfully, because I would have looked a bit stupid otherwise, got the same answer. So we do it in this difference method. All right. Now, the reason why I say I don't normally work this way is I would just be looking at it instead of a subtraction here. I would say, well, this is where I am. What do I need to do to get back to that number? So I've got to add something, okay, every time. And this is the number that I add, and this can be described by 0.5 n. So I would have just gone straight and written 1.5 n squared plus the 0.5 n gives me the un. So I'd have just written straight like that, but I know it's done like that in the book, so we've gone through it. Okay. Any questions on that? Any comments? Is that easier or?
I think it's more confusing.
Yeah. What I would say, guys, is sometimes in exams that they like to lead you down this route because you need to understand that a quadratic is made up of a quadratic and a linear part. So this does lead us in, for instance, do you remember when, if I said to you, solve, let's say 2x squared equals minus 5x plus 7, all right? So this is two different things, but this is the difference between a quadratic part and a linear part, and then we rearrange it to have 2x squared plus 5x minus 7 is 0. So there is your quadratic, but it's made of a linear bit and a quadratic bit. So it's kind of following along, slightly different in terms of what we're trying to achieve, but that kind of idea that the quadratic that we want is made up of a quadratic component and the linear component added together. Okay. So you have two processes. Okay. Personally, I find the algebraic one just a little bit more consistently easy to do. Sometimes these numbers are not quite so nice, especially when you get loads of fractions and things. Because look how many numbers I've had to deal with, whereas the algebraic one, really all I needed was these three things. Okay. But you've got both methods. It's up to you how you want to, which one you want to do. Okay.
Do we have to know both, or can we just use one?
The level that you guys are working at, because you're all great, you should be aware of both of them. But if you are...
required to learn both of them? Like on the
should I just say yes now? I'll say yes. I tried to make it clear that in sometimes a question will just say do it however you want to do it, but there will be other times when a question will lead you down a particular route, and there will be intermediate questions that you will have to be able to answer. Okay, so be prepared to be able to do both. In this context, if I just ask you, so for instance, if I said to you, like one of the questions in the book is, it's 3, 8, 15.5, 25.5, and 38, and I said to you, tell me what the explicit formula is, you can use whichever method you like. Okay? Because I'm not being specific. All right. So would you like me to go through this one with you, or do you think you're okay with it? We go through it. Okay. Right. So if you are not needing to, then feel free to mute me. Don't log off, but you can mute me and get on with it yourself. All right. So this is practice 6. It's question 1, L, I believe. Okay. So have a go yourself if you want to. Mute me, but maybe you can look at the screen afterwards. If you're happy, if you want to go through it, stay with me. All right. Give you 10 seconds to get on with what you want to do. For those of you that are staying with me, which method would you like to go through?
The algebraic one.
Is that a consensus for the algebraic one?
Yeah, that's fine. Okay, I kind of wanted to go through the other one, but it's fine.
Well, let's do both then. Let's try and do both. Okay. So, first step for both of them, or I tell you what, guys, my time's about to run out. So, can I stop and start again? Okay.
Yeah.
Pause my. So, the plan is to go through algebraic method first, and then we'll try, if we've got time, go through the other method. Okay, so first off, we still need to work out what the numbers are. So I'm going to go for 3 to 8 is plus 5. 8 to 15.5 is what?
7.5.
Okay, 15.5 to 25.5 is plus. Then it's plus 12.5. Okay. Second line of difference is the same for both ways, is plus 2.5. Okay. So either way, so I can try and remember that this 3, okay, the 3 is found by doing which equation algebraically? Yeah, A plus B plus C. Are you all happy with where that comes from? Yeah?
Yeah, I think so.
Well, it's putting 1, as in n is the first term, into an squared plus bn plus c. Okay? If I put 1 in for n, okay, you get a times 1, b times 1, and c. Yeah? A plus b plus c. Right? This one, 8, is n equals 2, and it would be a times 2 squared, which would be 4a, plus 2 times b times 2, which is 2b, and the plus c, because there's no one. Right, so this would equal 8, so I can just write that if I like. 4a plus 2b plus c equals 8. But I don't need both of them, I only need one of them. I could use any of them, but I don't. Why would I pick this one over this one?
Like the least, like it's the simplest.
Exactly, right? There's only one A. It's nice and easy. This one could be easy to do, but it's slightly more numbers, right? The next line down would be the difference between 4a plus 2b plus c and a plus b plus c. So 5 there. The second line of first line of difference is 5 on that number. What would this one be? Do you remember?
2.
3a plus b equals 5. Yeah. 3a plus b equals 5. So that's the second equation. And then the final line, because I can stop there because it's a quadratic, that number there, what's the algebra for it?
A equals 2.5.
Exactly. All right. If I don't remember where these come from, well, do the subtraction with the algebra.
How did we get to 3a plus b?
Okay. How do you get 5, Liam?
The difference between 3 and 8?
Okay. How do I get 3a plus b? Well, it's the difference between 4a plus 2b plus c and a plus b plus c. So I either do 8 minus 3 gives me 5, or I do 4a plus 2b plus c minus a plus b plus c equals 5. Okay, when I simplify this, I get 3a plus b. Okay, and I haven't done it, but if I had a third one done and then had another equation for this one, and you can look in the other video for that, I show that this is 2a. All right.
How do we go from the 3a plus b to 2a?
Well, that's what I was just saying. Okay, so this would be 9a plus 3b plus c. Then this one would be 5a plus b if I subtract those two, yeah? And then if I then subtract those two, 3a plus 5a plus b subtract 3a plus b, what do I get? 2a, yeah? The same way that I found plus 2.5 by doing 7.5 subtract 5. So I'm either doing it with the numbers or the algebra, okay? So again, more detail in the other video. So now the job is to figure out what A, B, and C is. Well, if I look at that one, I can't do it. Could be anything. If I look at that one, I can't do it. So this is the way I start. So if 2A's are 2.5, 1A must be 1.25.
Yeah.
Stick that into here. So 3 times 1.25 plus B has to equal 5. Well, that is 3.75. So what must B be?
Equals 1.25 as well.
1.25. Okay, again. So up here, look, I've got 1.25, 1.25, okay, plus something has to equal 3. So 1.25 plus 1.25 is
2.5.
2.5. So 2.5 plus something equals 3. So what must the something be? 0.5. Okay. So I've got C is 0.5, B is 1.25, and A is 1.25. So that leaves me with being able to fill in A, B, and C and say that UN equals 1.25 n squared plus 1.25 n plus 0.5. Okay, so that's the algebraic method. You want to do the difference method now.
I think I'm fine with this one.
Well, let's not give up. Let's try it. So you've got both options if you like. We'll do the same one again. So we know what the answer needs to be. 3, 8, 15.5. Am I doing the right one here? 25.5 again.
Yeah.
38. So same thing again. It's plus 5, plus 7.5, plus 10, plus 12.5. That's the first line of difference. Then it's plus 2.5, plus 2.5, plus 2.5. So we've done the same starting procedure. If the second line of difference is constant, that means we have an squared, and we need to know what the A is. So we've figured out before, and it's really the same starting point, isn't it? A has to be this number divided by 2, yeah? Which equals 1.25. So actually, this method gets me to A quicker. I already know that A is 1.25. All right, but isn't it the same thing? Because actually, that number divided by 2, that's all I did before, didn't I? 2A equals 2.5. That's what I had before. Or just knowing that that number divided by 2 equals A. It's same thing, right? Okay, here's where it diverges from the other method then. We have to make a table of values. So I know that my n being 1, 2, 3, 4, well, un is 3, 8, 15.5, 25.5, well, 5 is 38, okay? Well, what I've done is I've figured out that so far I know it's 1.25 n squared. So I've got to put in, change the colour because I like it, 1.25 n squared, all right, is my starting point. So now I need to figure out what numbers am I currently at. I've got to figure out what 1.25 n squared is. So this is where it starts getting a little bit more kind of cumbersome, because what is 1.25 times 1 squared? Well, that's easy enough. It's just 0.25. But the next one is 1.25 times 2 squared. 1.25 times 3 squared. 1.25 times 4 squared. 1.25 times 5. So can you work those out for me?
2 and 4, I haven't done 3 and 5 yet.
Well, what's 2?
2 is 5.
3, I believe, is 11.25.
And then 20.
And then 4 is 20, and then I don't know what 5 is.
31.25.
31.25. Okay, so I've got those. So this is the thing. This is where I'm at. I'm here. Okay. I want to be here. This is where I am. This is where I want to be. This is where I am. This is where I want to be. So what's the difference? So what we do is we work out the difference. So un minus 1.25 n squared. Well, what do I need to add on for here to get to here? Well, it's 1.75, right? This one is add 3. This one is add
From 5 to
15.5. So I'm at 11.25. I want to get to 15.5.
All right. You need to add 4.25.
20. I'm here. I want to be there. That's an easy one. 5.5. This one, I'm here. I want to be there. I've got to add on
6.7. I got it. 6.75.
Yeah. Okay. So then we say, right, is there any pattern to this? All right. So this we treat as a linear sequence. So this is the linear part. Okay. And we can see that this is plus 1.25 every time. Yeah. So I can actually generalize this bit, okay, and say that this bit is actually 1.25 n.
Just said this from the start, though. Like how we already had the 1.25 from 2a.
But we're not there yet. This isn't 1.25 n. Because 1.25 n would give me 1.25, but I'm at 1.75. So what do I need to add on? How much? Yeah, 0.5, isn't it? 1.25 lots of 2.
0.5 is 5.
Yeah, okay. 1.5 lots of. So does it work? Can we check it? We all happy? Yeah. 1.25 times 4 is equal to 3. Sorry. No, what am I saying? That would be 5. I'm thinking something different. 1.25 times 4 is 5. 5 plus the 0.5 gives me the 5.5. Okay, so I've confirmed, I've verified it. So that means that this sequence bit is here. So now I can say that n minus 1.25n squared equals 1.25n plus 0.5. So sorry, Satya, I jumped in. What were you going to tell me?
Would it be un equals 1.25n squared plus 1.25n plus 0.5?
It would. Because like I said, I think of it like I'm here, I want to get to there, all right? So what do I add on? Well, I've got to add on this number, but that number changes. So actually this number is given by this. So I would say that add 1.25n plus 0. So I think of it that way round, but I know they do this in the book. So up to you how you want to interpret that at the end. Okay. So we ended up with the same answer again, which is nice.
Yeah.
Right. Go for it.
Sorry, I don't mean to interrupt. Sorry, but I was just a little confused when we got the 0.5, but now I realized it's the 0.75 to the 0.25, 1.25, right?
Say that again with a little bit more detail. What do you mean?
Sorry, I was just saying the 0.5 at the end, the plus 0.5
Yeah.
at the end of our formula, that comes from the difference between 1.75 and 1.25, right?
Exactly. So again, same sort of process. I know it's add 1.25, so it's 1.25n for a linear, but 1.25 times 1 gives me 1.25. And again, it's the same sort of process. I'm here, but I want to be here. How do I do it? Add 0.5. But because we've already done the quadratic bit and we've done the linear bit, the bit left is the constant bit, so all of them are going to be the same. 1.25 times 2, okay, is 2.5. I need 3, so it's add 0. It will always be the constant bit at the end, okay? So that's how we found that. So you've got both methods. Make it a bit clearer. My scroll.
Yeah.
Which one do you prefer now?
I prefer the difference method because
Yeah.
even though it's a bit longer, it's a lot simpler to understand.
Okay.
At least.
I still prefer the algebraic.
Yeah.
Yeah, the difference one, not the algebra one.
Yeah. Okie doke.
All right.
In my opinion, the algebra one, if you're not quite there yet, don't disregard it completely, because especially at the level of that you guys can work at, we definitely need to be able to deal with algebra stuff like that. But okay, at the moment, if you want to work with this difference method for this process, no problem at this stage. Okay. So I guess it's now, well, it's pretty much time anyway, but to 6, page 284. Have a go at a couple. Next week we'll finish this off. All right.
Thank you, Mr. Fox.
All right.
Thank you.
Have a good
Have
one.
a good day.
Bye.
Those people. Yeah, go on. Carry on.
About the win rate thing, and I was
Oh,
saying.
I
this
thought
morning-
that was a bit mean because you guys are doing all right at the moment.
I was gonna say, yeah, we're doing.
Yeah,
We've gotten better since.
definitely. It can all go wrong. How long does it take for a Chelsea manager? What, 18 months before they're sacked?
I mean, At least that's longer than the time Mourinho spent at Tottenham.
True, yeah. Well, all right.
Bye.
Have a good weekend. How about you, Ryan? Are you still with me for a question, or?
It's just taking a very long time to leave.
I will just leave for us both. Have a good weekend.